Hey everybody, today in math we are going to be taking a look at a multiplication strategy. So a strategy is an approach that you can use to help you solve problems. There are different tools that you can use to help you solve, so this is just one of them. And it might be a review, and if so, that's fine. The purpose of reviewing, though, is that this is a very useful tool in math. So as we work with, it works for smaller numbers, but it also works for bigger numbers. So we're going to start small and build up on that. So might sound familiar, partial products, okay? And it's a multiplication strategy. And sometimes I've actually heard it being called the break apart strategy. That's not the real word for it, but some people call it the breakup strategy or the break apart strategy. And I'll show you why. So we're going to look at a super simple example, and then we'll look at some more complicated examples. So if we look at something like 7 times 8, okay? In order to solve, and I know that this is a basic fact, but I want to show you with something simple. In order to solve this, we could just straight up solve it. We could use standard algorithm. We could use area models. There's all sorts of ways. But this strategy, the partial products, asks you to look at a factor or both, but for right now we're going to focus on one factor, and you can go ahead and break it apart. So in order to solve this, I might say, well, wait a minute. I always get stuck on this fact, but what if this is the one that I break apart? Okay, so instead of calling it 7 times 8, what if I break it up? And there's different ways you can break it up. I want you to think right now. How could 8 be formed? Well, 8 could be formed with 4, and 4 is my first thought. You could do 7 plus 1 is 8. You could do 6 plus 2 is 8. So all different ways. So there's different ways to break up 8 and make it. So let's use my first one. Let's use 8 was also 4 plus 4. Okay, and what the partial product strategy is going to tell us is that we can take this 7 and we can multiply 7 times 4 and 7 times 4 and get the exact same answer as if we just did 7 times 8. Okay, so let me quickly show you how that works. So let's just do an area model really fast. I think that's a nice visual. So if we were multiplying 7 times 8, we just learned that instead of using 8 as a factor, we could break it up and use 4 and 4. So let's break it up in our area model. Instead of using 8, we can use 4 and 4. And if we multiply, we're multiplying 7 times 8. So I like to put my multiplication symbol. But we can go ahead and instead of 8, 4 plus 4 equals 8. So we broke it up. So 7 times 4 here is 28. And 7 times 4 here is 28. Now, if you go back to the name of this strategy, it's called partial products. And when I think about that, I think part of the product or the answer. So look here, when I split up 8, so remember it was an 8, and I'm going to use that broken heart because I split it up. When I split up 8 and multiplied out 7 times 4 and 7 times 4, right here I got part of the product here and part of the product here, and so these are called the partial products. Now, if this is part of the answer and part of the answer, to get the full answer, I have to add up my partial products. So 28 plus 28 will give me the full product of 7 times 8. So 8 plus 8 is 16, 2 plus 2 is 4, plus 1 is 5. So 56 is the full product. Okay? And the last thing I want to show you up with this problem is that how to write it. So what we really did was we did 7 times 4, and we did 7 times 4, and the model helps me see that. I did 7 times 4 here, and 7 times 4 here. And what did you do with those? 7 times 4 and 7 times 4. When you were done, we added them. And that is an expression that shows this 8 being broken apart. This is actually called, has a fancy name. Everything in math has a fancy name, right? So this is called the distributive property. And so really what you're doing is you are distributing. I always think of the word distribute. I think of the Amazon Prime truck. They have all their all the packages in the truck, and then they have to distribute them or hand them out to the houses, right? So distribute means to hand out. And so what we did in this math strategy is we took the 8 and we handed it out. We handed some out here and we handed some out here. Okay, so the distributive property tells us that we can go ahead and use break apart, and I'm going to read you the exact definition: a property of multiplication that can be used to create an easier problem. So we use this, distributing it, to create easier problems. Okay, one last thing I'm going to show you. This was just a single digit by a single digit, so I'm going to step it up a little bit and just show you bigger. Let's do something like, I don't know, 35 times 6. So the same rules apply. I can go ahead and break apart. So when these are my two factors, I kind of look at it for a minute with my eyes. Which one do I want to break apart? Well, 6 is already kind of like a basic fact. 35 is kind of complicated. I don't know. I think if I was going to choose, I'm going to take this 35 and break it apart. Now, I don't want to confuse you. You can break apart both, but we're not there yet. So let's just focus on one. Let's break up the 35. Now, here's another question. How do you want to break up 35? I don't care. You can do it any way you want. For me, when I look at it, I think about place value. And my first thought when I looked at it was, well, 35, if I want to break it apart, I kind of think of it as 30 and 5. So what if I use this property, distributive property, what if I distribute the 6? What if I hand out this times 6? But instead of handing out the times 6 to the whole 35, what if I hand it out to the 30 and then to the 5 and I add them up? So really, I would be doing 6 times 30. I would also be doing 6 times 5, and I'd add them up. Now we can use basic facts. So 6 times 30. 6 times 3 is 18 with a 0. 6 times 5, okay, I'm thinking of my basic facts. 6, 12, and 18, 24, 30. Okay, so that's 30. So right here, I have my partial products. Okay, this is part of the answer to 6 times 35. This is part of the answer to 6 times 35. And if I add up the parts of the answer, 180 and 30, I will get the total product. So, and you can just do it on the side, 180 plus 30. 210. Okay, and even another multiplication strategy works for this. So think about really fast, if you think about standard algorithm, 35 times 6. If you think about standard algorithm, it's actually doing the same thing. Okay, really here, you're multiplying 6 times 5, correct? So 6 times 5 is 30, we just said. And really here, you're multiplying 6 times, well, what is that? It's not just a 3. Look at its place value. It's actually a 30, right? 6 times 30. And 6 times 3 is 18 with a 0. So look at that. It's the same thing. 6 times 5 and 6 times 30. And together, this 30 and this 5 make 35. So really, it's 6 times 35. And if you add up the partial products, you get the full product. Okay? So I hope that that helped you, and we're going to do a few more examples in our notebook. And just the main takeaway is thinking, I don't have to just straight up solve the problem. I can actually use tools to break apart numbers. If you ever get stuck on a basic fact even, if you get stuck on 12 times 4, well, wait a minute, I could do 6 times 4 and 6 times 4, okay? So it can kind of start as confusing sometimes, and then when you realize what this strategy is actually telling you, it's actually trying to help you say, wait a minute, you don't have to do these harder facts. You can kind of split them up into easier facts, and the distributive property tells us it's going to work if you do that, okay? So I hope this was helpful. We'll do some practice, and I hope this is a strategy that you can use to help solve multiplication problems this year.